if we take a look up here at this, we want to look at the first step, which is a GCF. And when we're working with the GCF, we want to just, we can start just with littles. I mean, of course you can look at this and start as big as you can, but so let's just say if it was 10 and 100, you go, oh, 10 goes into both of them. Then fine, use a 10. But what if it's, you know, 54 and 96 or something like that, you know, and you're not sure if 3 goes into both of them or 6 goes into both of them, you know, well, you know that 2 goes into both of them, so you can start with the 2. Also, 3 goes into 54 and 3 goes into 96, because when you add those two numbers up, 5 and 4 is 9, divisible by 3. So you know 3 does. If you know 2 and 3 go into both numbers, then you actually know that 6 does. But these are things you'll learn, and if you want to take steps, baby steps at it, that's fine. Just start with 2's, and you always start, you know, prime factorizing it. So breaking it down by primes. And to set up the prime factorization, I like to just set it in a nice big upside down division. Okay, so I got 10a cubed b to the 4th plus 8ab cubed. Okay, and I'm going to take a look at what goes into these things. And so I noticed that 2 goes into 10 and 8 because they're even. So 2 goes into 10 5 times. And 2 goes into 8 4 times. And then I will take a look and say, well, can I take more out of this? And I can't take any more out of the numbers, but what I can do is start pulling letters. So I look at one letter at a time, and I want to look at the lowest exponent on the letters. Start with A and say, which one's lower, A cubed or A? A. And I'm just going to, and if there was 3 pieces, then I would keep going until I found the lowest one in all 3 pieces. And that's this one. And so I can pull out an A, and now I can rewrite 5A. And so when you pull out, you're dividing it out. And when you divide, you subtract exponents from chapter 4. So 1 from 3 is 2. And it's really that simple. And 1 from 1 is none. So there's just nothing, no A in there. And then we can move on to the B's and say, well, which one's the lowest? And 4 or 3, and it's 3. Okay, and then so now I've got B to the 3, and I have 5A and squared, and B to the 4 minus 3 is 1, and B3 minus 3 is none, so I'm left with just this. And I can finalize it all up by writing it in my GCF form. The GCF is here, so that equals 2 times A times B cubed. And then if I wanted to write it as an actual function that I'm going to continue to work with, or 2 functions, or two factors, then I would look at 2AB cubed times what's ever left. And what's left is 5A squared B plus 4. And that's a one-step method, meaning I can't factor it anymore. The GCF finished the job, so I'm done. Okay? This 3-step method is one that works pretty quickly. Our first step, again, is GCF, and our next step is a star variable and parentheses. And so, in this case, the star is that number that's out in front, is the first coefficient. And there is no number, and so therefore there's no GCF. Well, there's no GCF Also because there's not an extra a in every single one of them or an x in every single one of them. Okay? And so I can't pull out a GCF, so I go straight to the star variable. And what this does is it gets rid of this guy, and it has no star, so therefore there's no star cleanup. If there's no star cleanup and no GCF, that means all I'm really doing is 2, 3, and 4, and that's what makes it a 3-step method. Okay? So I take down my parentheses and my variable. Okay, there's 2 A's, so I'm putting a variable in each one. And then I can move on to my signs. And the signs are very simple. This first sign always comes down. It just comes straight down. Minus. And this sign tells me whether these two signs are the same or different. Plus implies that the signs are the same. Okay? And minus implies that the signs are different. You know, I kind of created this to just say difference, different, sum, or same. It's real simple. Try to keep it in your head. So I'm looking at this, I see it's the sum. That means that it's the same. So these two signs are the same. If this is negative, then this is negative. Okay? And so there, then I just go on to my next stage, which is product and sum. Product. Oops, sorry.
14?
Yeah.
Okay, thank you.
But we want a 14 in that middle one. Okay, product and sum is just the product, meaning the first times the last, which is 45. And the middle number, which we changed real quickly because 9 and 5 don't add up to be 13, which we thought it did when we created the problem. It adds up to be 14. A little better way to look at it. So two numbers that multiply, two numbers that multiply to be the product is 45, and two numbers that add to be the sum is 14. Okay? So the sum, in this case we want to know what's the sum doing, and the sum is always doing what the second sign in the trinomial is doing. Not in your two binomials, in the trinomial. So it is adding, so we're adding to get the sum. So two numbers that multiply to be 45, and we have 45 and 1 and 3 and 15 and 9 and 5. And which one of those add to be 14?
9 and 5.
9 plus 5. So it has to work with both of them. Once you have that, it's the big number first, every single time. So it's just 9 and 5. And that's the way the three-step method works. Okay?
Could you repeat what you said about the second sign having to do with...
The second sign is always what we're doing in the sum, and it's always the second sign in the trinomial, not the second sign in the binomials. These are two binomials.
So if it's a positive, then it's 9 plus 5. If it's a negative, then it's 9 minus 5.
Yes.
Okay.
Okay? And so then we're done. And we have the answer as a minus 9 and a minus 5. Now, the three-step method, or 4-step, or 5-step, or one step can always have multivariables. Typically you'll find some that have two variables, and the way you want to deal with that is the same way. We do the GCF, but there's no GCF that goes into all of these. B doesn't go into all, A doesn't go into all, and nothing goes into 1, 2, and 8 except for 1. So we go straight to the second step. There is no star variable, and that's what makes this, since there's no GCF and no star variable, that's what makes it a three-step method. So we go straight to the parentheses. Variable. Now here's a variable, right? The a squared. But there's also a b squared on the other end. And so on one end of the parentheses we put an a, and on the other end we put a b. Okay? And then that's it. We're done. Okay? With that step.
Why is it a three-step when you're saying there's no GCF and there's no star variable?
Because you're only doing 2, 3, and 4.
Because we're only doing steps 2, 3, and 4.
But you said there's no star variable.
There's no star, but there's still a variable.
Okay.
There's still a parentheses and variable.
Okay.
There's just no star.
There's just no star, but there is a variable.
Yes.
So that's actually a two-part kind of deal.
So now we want to do the signs. We look at these. This comes straight down. So we have a plus. Okay? And this one tells me whether they are the same or different. In this case, it tells me that they are different because it is a difference. Okay? That means these two signs have to be different. If this is plus, then this has to be minus. If this were minus, it would have to be plus. Just goes without saying, but you always have to say it. So now we step on to the fourth step, which again is product. Now again, product is the first number, which in here is it's actually a 1, times the last number, or the third coefficient. So the first coefficient times the third coefficient. And we just look at the numbers. We don't care about plus or minus. I've created this 5-step method to not care about plus, minus. We don't have to think about that. All we have to think about is, what is 1 times 8?
8.
And what is the middle number?
2.
And then the hard thing to think about in the sum is what's happening in the sum. And this sign right here is what's happening in the sum. There's either a difference or there's a sum. Okay? And if it's a different problem, we find a difference. Okay? If it's a sum problem, where we're finding the sum, we have the same, two same signs that we'll end up adding. And I'm going to show you the clam method when I'm all done, just to prove that these are all correct. Okay? So, again, first times last, 8, middle, 2, and two numbers that multiply to be 8. So it could be 8 and 1. And we always go big number first. So 8 and 1, 2 times 4, 3 doesn't multiply. And there's no other number besides 4. So now we got those products, or those factors. So which two factors subtract to be 2?
4 and 2.
4 and 2. So it's not this. So it has to be this. So it's 4 and 2. And it's that simple. So now we have two binomials, a plus 4b times a minus 2b. And that is what's happening. Now, if I take this to try to prove that it's correct by using that clam method that we talked about. A minus 9, A minus 5. The clam